Hi, I'm Ian Cunningham from Vector GB, and welcome to this episode of Engineering Jigsaw, episode foundation level number 2, called What is an ECU? Well, let's go in and see what we're going to look at today. Well, in this episode, we're going to look at what an electronic control unit, or ECU for short, is and does. Now, just before we get too far into this and before anyone gets too excited, there's a new generation of ECUs coming into cars, and these are called high performance computing platforms, or HCPs for short. We're not going to cover those today though. They're a little bit more advanced. So we'll work with a basic ECU to start with, and maybe in the future we'll have an episode on what HCPs are. If that is something that's interesting for you, obviously please let us know. The more people we have requesting a topic, the more likely we are to do an episode to tell you about that topic. And yeah, before you watch this episode, it might be useful for you to watch our first episode F1, foundation episode number 1, called A 50,000 piece jigsaw puzzle, just to give you a bit of a background of generally what vehicle EE systems have going on in them right now. So let's think about that phrase, electronic control unit. So electronic, well, in the modern world, nearly everything seems to have electronics built into it in some way. And there's a name for this kind of thing. It's called an embedded system. So the fact that the electronics is built in, we can say it's embedded into that product. Now, embedded systems perform a single specific job. And because of this, they have specialized embedded software to do that job. So embedded systems are not like a computing system, as you may know, a home computer or a mobile phone, because computers and mobile phones and tablets, they can do quite a lot of stuff. So they have generalized software that lets you add additional software to it. Embedded systems, they come with software on board usually when you're buying them as a consumer, and that's it. You might be able to get an upgrade to fix a bug, but you can't add additional software yourself usually, not without a lot of effort, at least anyway, for a normal person on the street. And embedded systems, they're really all around us. So heating controllers and air conditioning systems, laundry and kitchen appliances, so washing machines, tumble dryers, microwave ovens, cookers, even toasters have embedded systems with them nowadays. And of course, if we think about vehicle EE systems, well, these contain embedded systems too. And these embedded systems that we have inside vehicle EE systems are the ECUs. So the ECUs are the constituents of the EE system in a modern vehicle, or at least some of the constituents, and they are embedded systems in their own right. So that's the first word, electronic. We'll come back to the electronics in a little bit, but let's just think about the next word we have, which is control. So control is an engineering discipline that aims to achieve a desired level of performance, and this is often done via applying rules. So what's an example of a rule? Well, rule or logic is often used to express how or when we want something to work. So for example, if we get into a car, then if the engine is running and the window switch is pressed, then we expect the window motor to operate. So we can express this as a rule. So if the engine is running and the window switch is pressed, then operate the window motor. So this is a control function that we could put in to maybe an ECU that we want to put in our car to control how the windows operate. Now, just simple rules like this might not be enough. We might need to also perform some conversions between values. So for example, in a vehicle, we're able to measure the speed the wheels are turning at in terms of maybe a number of revolutions per minute, but we can't measure directly the speed that the vehicle is traveling in a straight line across the ground. What we are able to do though is convert the number of revolutions per minute that the wheels are going through, and from that calculate the vehicle speed. So for example, we might say that our vehicle speed in kilometers per hour is equal to the wheel speed in revolutions per minute multiplied by 3.6. And of course then, once we have that number, the result of that calculation, that conversion, we might want to use the results from that in our logic, in our rules. So for example, if the vehicle speed exceeds 5 kilometers per hour, then lock all the doors. So this is a drive away door locking function, which many of you will have experienced in a modern vehicle. And of course, in vehicle EE systems, the embedded software in ECUs is what's providing our control functions that we interact with and experience as we're riding around in a modern vehicle. And as well as all these functions that we interact with and understand, the ECUs also provide diagnostics and calibration capability and lots of other stuff. And all of this goes into a single box, a unit. Interesting. So that's electronic control and unit. We got to the unit just at the end there. Let's have a bit of a deeper look into the hardware. Well, unlike the microprocessor that you'll typically find in a home computer, ECUs use a special kind of silicon chip which is called a microcontroller. Now, the main differences between a microcontroller that you'll find in an ECU and the microprocessor that you'll have in your home computer is that a microcontroller comes with built-in memory and storage. So you might know with a home computer you can upgrade the memory, you can put more RAM in it, and you know obviously you can take out one hard drive and put another one in that's bigger. You know, put a couple of terabyte hard drives in where you only had a few hundred gigabyte hard drives previously. Well, microcontrollers, you don't have that ability to kind of change the hardware. The hardware is the hardware, and that's what you've got. So that's kind of step one. We have a microcontroller, a special kind of processor. I nearly said microprocessor, which is wrong. It's a special kind of silicon chip, special kind of computation unit that we have in our embedded electronics. Typically, these are relatively low power as well when you compare them to things like the processor that you'd find in a home computer or a mobile phone. Now, we've said that we want to have software, embedded software in our ECU, in our embedded system, and the software, of course, that we're running on our microcontroller needs to be able to interact with the other stuff in the vehicle. So the buttons, the motors, the lights, the buzzers, the things that go ding when you maybe do something that the car doesn't, or truck or bike doesn't like. And embedded software in general works in terms of numbers. So the software kind of mostly works in numbers. It's less true in some specialist fields, but in general, software is about numbers. And of course, electrical components like buttons and motors, they work with currents and voltages. So there's special hardware in ECUs which allows the conversion of inputs from electrical signals, whether that's a voltage or a current, into numbers. And also, we have the special output circuits that take the numbers in the microcontroller and create current or apply voltages to make things happen in the vehicle. So these inputs and outputs we collectively call I/O. And ECUs also use networking hardware to be able to share data, which is just numbers again. We're sharing numbers between one another via in-vehicle networks. Now, special treat for today's episode, I have a real live ECU here with me. Here it is. So this is a prototype ECU I have borrowed from our projects team, and because it's a prototype, we're going to take it apart and have a look at what's inside. Please do not try this at home. You can very easily damage the electronics inside an ECU. I'm doing this because this is no longer needed by our projects team, and it's not a problem if I actually break it by accident. One important thing, you can see here, there are the connectors that connects it to the motors, the sensors, the networks, the whatever in the vehicle. So let's get this into pieces. Right, here we are. inside my ECU. So here's the connectors that we just saw when it was in the box. And here is one side of the electronics. You can see there's lots of stuff there, hopefully. And if I just flip it over quickly, you can see what's on the other side. And there, that is the microcontroller. So there's lots of electronics in there. We can see there's all kinds of other bits of silicon chips doing stuff. I'm not an expert on embedded electronics, so I wouldn't like to guess at what any of them are apart from that one, because I know what that one is. But that's the insides of a real live ECU. And it all connects via the pins from the connectors, which are kind of along there, to the electronics. The electronics, obviously we have the software running here, and then the electronics is used to interpret the inputs and to generate the outputs that we need to make things happen in our vehicle. So that's that. So we just talked about the software again. So let's take a closer look at the software. Unfortunately, software is really hard to see, so I'm just going to talk about this. So we can, though, to try and make it a little bit easier, split the embedded software that's going to run on our microcontroller into layers according to what it does. And this will also help us understand what everything's going on. So the control functions that we run inside our ECU. So for example, the window control, the example we had earlier, we press the button while the engine's running and we expect the motor to operate. Well, those we typically have running on the microcontroller. We talk about those as application software or just application. It's quite common that people talk about that application. Now, the application is working with all these numbers, and we've got all that hardware which is working and turning electrical signals into numbers. And this process is managed by some special software, which is called basic software. You can think about basic software. It's a very, very, very roughly like Windows or Linux or iOS. It's a bit like an operating system. So your application kind of sits above that, and this basic software is what actually interacts with the hardware. So the basic software kind of provides the numbers that the application needs, and it takes the numbers and it makes the electronics do the right things to make things happen as we want to in the vehicle. So we glue these two layers, the basic software and the application, together with something called a runtime environment. Now, the runtime environment is really special. What it does is it means that the basic software only has to calculate things once. So, for example, our vehicle speed. We might have a load of different control functions in an ECU that need to know the vehicle speed. So we talked about locking the doors. There might be other things that we need to have vehicle speed for, like adjusting the radio volume or other jobs in our vehicle. So we don't want to have to calculate the vehicle speed over and over again just because we've got many, many different things that need it. So the job of the RTE is to say, well, basic software, you can calculate that once, and then we have this special software that has the job of taking the vehicle speed to everywhere that it needs to get to. And the same with any other input to the ECU. Maybe we've got a temperature and lots of functions inside a single ECU need to know that temperature. It's the RTE's job to make sure that all of those individual functions have the latest value of the temperature given to them. And it also does this with network communications. And this means, additionally, the RTE takes the outputs of our control functions in the application and it puts them down into the basic software so that the basic software is able to make the things happen in the vehicle that we want to have happen. So that's a very quick idea of how we can cut up the basic embedded software into a basic software, runtime environment, and the application. And it's the application that as users of a vehicle, passengers of a vehicle, we really feel and interact with. So it is what is really turning our button presses into window motors moving with the help of the basic software. So that's a kind of our look at the software. So that's all we're going to talk about today, that very quick overview, introduction. So we've talked about the ECUs that are being built into modern vehicles. We've looked at how the software inside an ECU is able to be layered, and then what each layer is responsible for, what it does. Now, it's important to mention at this point that Vector provides basic software to meet a set of specifications called the AutoSAR standard, published by the AutoSAR Consortium, and that software we sell is called MicroSAR. We also sell lots of other tools in association with MicroSAR. Now, we've also looked at the role hardware plays inside an ECU, and I showed you some real hardware. I've still got it here. It's still in pieces. So I'll have to get that back to our projects team before they realise I've taken it. And yeah, we saw there's lots of little components there. And of course, there's lots of functions in an ECU. So there's lots of lines of software code. And if we counted all of these parts up, there would be, well, many tens of thousands of lines of code even, plus hundreds of electronic components that we're putting together into our ECU. So really, we can think that ECUs are another 50,000 piece jigsaw puzzle that goes into our jigsaw of the vehicle EE system. So thank you very much for joining me today. If you are interested to know more, well, I mentioned this thing called AutoSAR, Standards and Specification and Consortium just now. So we have an episode which we will run, which will cover that in more detail, explain what AutoSAR is. We also, again, have mentioned networks and diagnostics and calibration. So yes, we have episodes already planned to cover those and to give some level of knowledge to you on those. And if you want to know more about embedded software in the context of AutoSAR, Vector does provide some free e-learning. So you can go to our e-learning portal and you can start to learn a bit more about AutoSAR if that's something that you want to learn more about. We also provide lots of detailed expert training courses on embedded software in the context of AutoSAR. And finally, we have a section of our website which is dedicated to Vector's products for AutoSAR. So we have our implementation, our version of the AutoSAR software, which is called MicroSAR, and we have many other products. We have products for testing ECUs and for designing the communications and the things they interact with. We also obviously cover high performance computing platforms and vehicle EE systems in general. You can find all that information on our website as well. So thanks very much for that, joining us today. If you have any questions on the content of this episode, or if you really want us to talk about HCPs, if you want more detail of that, then the usual email address, please email us at engineering.jigsaw@vector.com. Look forward to hearing your questions and your suggestions for future episodes, and we'll see you again for another episode soon.